Hello everyone, this is Mrs. Snook with section 2.6, Proving Angles Congruent. And we are going to be doing proofs today, this time using all angles. So the key to doing proofs is to draw your picture. So make sure you're drawing your pictures and then mark them. So let's get started. First one is given ray BX bisects angle ABC, and ABX equals 45 degrees. So let's draw a picture. And it says prove ABC is a right angle. So this is my clue to make my picture look like a right angle. And this is going to be A, here's B, here's C. And we're told ray BX bisects it, so I'm going to put a point X out here. And I'm told ABX is 45 degrees. So make sure you draw your picture, label all the information that it's giving you. Next thing you need to do is mark it. So because I am told that ray BX bisects angle ABC, that means that those angles are cut in half, and I've got two equal angles. So I'm going to mark them congruent. So right there I've marked my angles congruent. Now this proof, I am giving you the steps, and all you have to do is figure out the reasons. Remember, statements go over here to the left, and then reasons on the right. And this is how we're going to format all of our proofs. In the book, it will sometimes talk about doing a flow proof or doing a paragraph proof. Just do 2-column proofs every single time. Don't worry about those other formats. So the first thing it says is ray BX bisects angle ABC. First thing that you always put down every time, all the time, is the given. So that one's given. We then see angle ABX equals angle XBC. And a moment ago I mentioned bisect, and I said because of bisects we're going to mark them the same. So that's the reason for this one. It's a definition of bisect. And I'm going to go ahead and mark my picture 45 degrees for that one as well. And then it says angle ABX plus angle XBC equals angle ABC. So what we're doing here is we're adding angles. That's angle addition. Okay. Next thing is we have angle ABX equals 45 degrees. Well, check up in your given. It's right there. So this is a case where we didn't put all the given at the front. You can, it's probably easiest is to just put all your given in the first step. But you don't always have to. You can also put it in later. So that's a given. And then we had angle, check this out, angle ABX equals angle XBC, and angle ABX equals 45 degrees. So our first ABX, this 45 degrees, that's a substitution. And then my second 45 degrees, this one right here, that comes from transitive property, because you have A equals B and B equals C, therefore A equals C. So we did a transitive property and we did a substitution. Now, transitive property is a special case of substitution, so I would accept substitution here. If you wanted to, you could also say substitution / transitive, if you wanted to do both, but substitution is just fine. Then we have 90 degrees equals angle ABC. So I did have 45 plus 45, now I have 90. That's combining like terms. And then lastly, we state angle ABC is a right angle. Here's a vocab word. Doesn't right angle mean the angle measures 90 degrees? Isn't that what we have written in our previous statement? So therefore, definition of right angle. And this one's done. Next proof. Given angle 1 is complementary to angle 2, and angle 1 and 3 are vertical angles, prove angle 2 is complementary to 3. Draw a picture. We call this angle 1, that's angle 2, and we are told no complementary. Let me change my picture. Here's angle 1, here's angle 2, and I know 1 and 3 are vertical angles. So there's angle 3. So there's my picture. And we're going to prove that 1 is complementary to 3. First it says angle 1 is complementary to angle 2. That's given. Next one, angle 1 plus angle 2 equals 90. Notice we had a vocab word, complementary. So one of my hints for you is anytime you see a vocab word, think definition of. So I'm thinking, is this definition of complementary? And then I notice angle 1 plus angle 2 equals 90. That's what complementary means. As you add them together, they equal 90. So this is definition of complementary. The next statement is angle 1 and angle 3 are vertical angles. That's the other piece of the given. And then we say angle 1 equals angle 3. That's because they're vertical angles. And we have a postulate that says vertical angles are congruent. So you could just say vert. And then we have angle 3 plus angle 2 equals 90. So check this out. We started with angle 1 plus angle 2 equals 90. Now we've got angle 3 plus angle 2 equals 90. What changed? Angle 1 became angle 3. And I know they're equal to each other from my previous step, so all we did is we plugged in angle 3 for angle 1. So this is substitution, and then now we're going from this equation, angle 3 plus angle 2 equals 90, to angle 2 is complementary to angle 3. And that again is definition of complementary. All right, now we're going to do one with segments and midpoints. I told her we were just doing angles, but I'm throwing in a segment proof anyways. So given AB, that's distance, AB, equals the distance EF, make sure you've marked it on your picture, and I look there, it's already marked for me. And then it says B is the midpoint of AC, so immediately mark AC as the midpoint. B is the midpoint, so then BC would be congruent with AB. So make sure you mark them the same. And then we have E as the midpoint of DF. Well, EF is already marked with one tick, so mark DE with that same one tick. So mark your picture. We're going to prove AC equals DF. We have B as the midpoint of AC and E as the midpoint of DF. That's given. AB equals BC, DE equals EF. Look at your picture. They're marked the same. Therefore, they are the same. And we mark them because of midpoint. So definition of midpoint. And then we said AB plus BC equals AC. So that's adding segments together. And DE plus EF equals DF. Also adding segments together. So this is your segment addition postulate. And then notice, look at our first equation, AB plus BC equals AC. Now it says AB plus AB equals AC. And if you notice what changed, BC turned into AB. And we already know AB equals BC from up here. Therefore, all I did was a substitution. Look at the second half of the statement. The same thing happened. EF plus EF equals DF. So that was also a substitution. Next step. AB plus AB equals AC. That became 2AB equals AC. So we just added those two ABs together. Not addition property of equality because it didn't happen on both sides. Instead, this is combining like terms. And then, check it out. We have 2AB equals AC and 2EF equals DF. And then from there, 2AB suddenly turned into EF. What happened there? How did 2AB become EF? Sorry, how did AB become EF? How did this happen? AB became EF. Well, on the picture, aren't they all marked the same? Don't they have the same mark? And why did we mark them the same? Because it was given. So that's given. Now we got 2AB equals 2AF. So both sides got multiplied by 2. This is your multiplication property. And I know from here 2AB equals AC. 2EF equals DF. So that's a substitution. Okay, here's another one. We are given that angle 1 and angle 3 are linear pairs, and angle 1 and angle 4 are a linear pair. So look at your picture. They did draw them. They look like linear pairs. First thing you're going to say is given. This time we put all the given up front. And then it says angle 1 is supplementary to angle 2, and angle 1 is supplementary to angle 4. Well, that comes straight out of our linear pair postulate. So this one wouldn't be definition of linear pairs because we have a postulate for that. And then, because both of them, angle 1 is supplementary to 2, and angle 1 is also supplementary to the 4, so 2 and 4 are both supplementary to the same angle, that's our congruent supplements theorem. And that one is done. All right, that is it for today. Thank you for watching and have a great day.